All right, good morning and welcome to Master Talker online class. Today we'll be talking about the polar form of a complex number. Okay, the polar form of a complex number. Now, there are things you need to know before you find the polar form of a complex number. If we have um, if we have a complex number like this, a complex number is written as z is equal to x plus yi or iy. Okay. Now this is called the regular Cartesian form. This is the regular uh, Cartesian form. Now, but from this place, let me show you something. From this place, let's have this. Watch me now. This is your y. The y-axis is called the imaginary part. Okay, while the x-axis is the real part. Now, if I have this, that's the complex number. Okay, and this side is the y, this side is the x, this side is the x. If I trace this side to have that here is x. Now let me have that here is my, let me call it alpha. Okay, now okay, let me call it theta for the main time. Let me call it theta for the main time. Sine theta is equal to what? Sine is what? Here is r, please. Here is r. So here is y, not x. Y, because this is the horizontal, the vertical axis. So sine is what? Sine theta. Sine theta is equal to what? Opposite over hypotenuse, which is what? Y over r. So which implies that what? My r is equal to what? My y, sorry, not r. My y is equal to what? R sine theta. I hope you can see that. If you cross multiply, if this over 1, this time this y, this time this r sine theta. So let me get for cos theta. Cos theta is equal to, cos is what? Adjacent over hypotenuse, which is what? Adjacent x over hypotenuse r. If I still cross multiply, I'm going to have that my x is equal to what? R cos theta. R cos theta. Okay, so now if I put this in the equation, that z, my z, that z is equal to, okay, if I put it that my z is equal to x plus what? Iy. So let me now put it, z is equal to, I got my x to be r cos theta, okay, plus I got my y to be r sine theta, okay. So from this place, if you factorize r, you're having that z is equal to what? R bracket what? Cos theta plus what? I sine theta, okay. So this is called the polar form of which is the same thing as say, but don't forget that e raised to power I theta, okay, is same thing as saying cos theta plus I sine theta. So please, you need to know this formula, which means that z is equal to what? R in bracket of cos theta plus what? I sine theta, which is same thing as saying what? R what? E raised to power what? I theta. So this is called the polar form. This is the polar form. Where is my A? This is the polar form of a complex number. Okay? This is the polar form of a complex number. So for every complex number, this is the polar form. This is the polar form of a complex number. Okay? So that is that. So the problem is, what is my r and what is my theta? Now, my r is equal to, okay, let me find r using Pythagoras theorem. R squared is equal to what? X squared plus y squared, is it not? So therefore my r is now what? The square root of x squared plus y squared, and my r is called the modulus of the complex number. The modulus of the complex number. Okay, so the next thing is, what is my theta? If I take tan inverse, if I take tan theta is equal to what? Opposite over adjacent, which is what? Y over x. So to find your theta, To find theta, theta is equal to what? The tan inverse of what? Y over x. And we call this theta argument. We call this theta argument. Okay? So we call this theta argument. Let me clean the board and tell you the things you need to know. Forget about all these things I'm writing. They are rubbish. Let me tell you the things you need to know for polar form of a complex number. The normal form of a complex number is what? That z is equal to what? X plus what? IY. Then the polar form is what? Z is equal to r first bracket what? Cos theta plus I sin theta. You need to know this. Okay? Or you say that is equal to what? R e raised to power what? I theta. The both of them are called the polar form of a complex number. So, but for you to find the polar form of any complex number, you need two things. The two things you need is what? You need your r and then you need your theta. Once you can get your r and your theta, you are done. So what is our r? Our r is equal to what? The square root of what? X squared plus y squared. And it is called the modulus. This is the modulus. Okay? So the next thing you need to get is the argument. The argument is the theta. So theta is equal to what? Tan inverse of y over x. Okay? And sometimes I used to forget if it is x over y or y over x. I used to remember it by dy dx. So y must be up and x must be down. So that is that. So let us continue. So now the next thing you need to know, let's talk about, these formulas are very important, but now let's talk about argument and the principal argument. There are two things you need to know here: argument and principal argument. Let me clean the board. Okay? Okay, now let's talk about argument and principal argument. Okay, now you get your argument from okay, now you must, before you solve a complex number, to get your argument, you must draw the Cartesian plane to know where that complex number will fall. For example, if I have that z is equal to x plus yi, if you look at this now, x is positive and y is positive. So if you draw this, this is your positive y, positive x, negative y, and negative x. So this is positive, so it will fall here. If it's going to fall here, you draw a line like this. Okay, if you draw a line like this, you are getting that here is what? Here is the place you are looking for. Let me call it alpha. Okay, now alpha, to get your alpha, your alpha is simply the tan inverse of what? Y divided x, y over x. Okay, that is for the first plane. Okay, now to get your argument is the same thing as what? This your alpha, which is what? Tan inverse of y over x. Okay, now but for the principal argument, watch you, the principal argument, let me call it that is equal to theta, which is equal to what? The tan inverse of what? Absolute value of y over x. Please, you must use absolute value. Absolute value, this is the formula for principal argument. Okay, absolute value of y over x. But it depends on where you are talking about. This is for the first quadrant. This is first quadrant. Now, for the second quadrant, let's talk about the second quadrant. From the second quadrant, now you will now understand where I am going to. Please listen. So for the second quadrant, look at what happens in the second quadrant. I'm having that what? That z is equal to minus x plus yi or iy. Okay, look at this now. I'm having this. This is my plus y minus y plus x minus x. Now if you look at this is minus x, it will fall here anywhere around this side, and this is plus y, it will fall here. So both of them now, if you trace this and trace this, so they met here. So this is what I'm talking about. Okay, now if you look at this now, this is my alpha. This is my alpha. Now listen, for argument, watch you. First of all, I'll get my alpha. Let me say that this thing is the argument is theta as well. Please watch. First thing to get is your alpha. My alpha is equal to what? Normally tan inverse of what? Y over x. That is my alpha. But once it falls at the second quadrant, okay, your argument is equal to, listen, the argument is equal to 180 minus what? 180 minus your alpha. Please, very, very important. Your argument theta, let me call the argument theta. The argument theta is equal to what? 180 minus alpha. Please, very, very important. 180 minus alpha. Okay, then your principal argument, which is, you know that 180 is same as pi, so you can call it pi minus what? Alpha. Okay, pi minus alpha. Now the next one you're going to look at, but for your principal argument, principal argument says that what? That to get your alpha, you must use absolute value. I hope you know that it's no longer y over x, but y over minus x. Please, y over minus x. Okay, please, y over minus x. Don't forget y over minus x. But for principal argument is what? The tan inverse of absolute value of what? Y over that minus x. And you know that absolute value will always give you what? Positive. You see the difference between argument and principal argument. So this thing will give you positive. So now to get your principal argument theta is still the same thing here. 180 minus alpha, which is what? Pi minus alpha, because pi is 180. So that is that. But the difference is that in getting alpha for argument, you are not taking the absolute value to give you negative number. But in getting alpha for principal argument, you must take the absolute value. Please, that is the difference between principal argument and argument. So let's talk about the third quadrant. For the third quadrant, now for the third quadrant, look at what we are going to have for the third quadrant. For the third quadrant, I'm going to have that z is equal to minus x minus iy. Okay, so let us draw it now. This is plus y minus y. You must draw it plus x minus x. So now, where is it going to fall? It's going to fall, so here is the minus and here is the minus. Okay, if you trace both of them, it's falling here. So it fell at where? Okay, remember that I'm taking the angle that is what? The smallest angle with the horizontal. I don't use the vertical. Now for argument, normally for argument, okay, which is equal to theta, is simply what? Now we don't use 270. Please, we don't use 270. You know, here is from 0 to 90, here is 90 to 180, 180 to 270, but we don't use 270. For 180, for second quadrant is always 180 minus, but third quadrant is that number minus 180. Are you getting it? Because that number is going to be bigger than 180, so it should not be what? Alpha minus 180. Please, alpha minus 180. Okay, are you getting it now? Which is something as saying what? Alpha minus what? Pi. Alpha minus pi. Okay, so now, but the principal, and don't forget the way you get your alpha. Your alpha is something as saying what? The tan inverse of what? Minus y over minus x. Aha. So that is it. So which is it minus the 180. So that is that. But don't forget that for principal argument, which is theta, okay, is equal to what? How do you get it now? The same method, alpha minus 180, which is what? Alpha minus pi. But to get alpha here is now the tan inverse of absolute value of minus y over minus x. So but in this one now you are seeing that it will be the same thing here because minus has already cancelled. Okay, so absolute value of minus x minus y minus x, then minus your what? 180. Okay, or minus your pi. Okay, that is for the third quadrant. So for the fourth quadrant, because sometimes they will ask you find the principal argument of this, we are still going to take those questions so you understand what I'm talking about. Okay, so the next one we're going to talk about is the fourth quadrant. For the fourth quadrant, now for the fourth quadrant, look at what happened for the fourth quadrant. That is the only place there is a problem. Now watch, for the fourth quadrant we have that the principal argument, okay, where is it going to fall? That z is equal to what? X minus yi. Okay, so let's see where it's going to fall. You are going to draw it by yourself. This is plus y minus y plus x minus x. So this is plus x here, but minus x is here. So if you bring both of them together, they met here. So on the fourth quadrant, alpha. So now the argument here, argument is here is equal to what? 1 is equal to theta, which is equal to 180, sorry, not 180 but 360, sorry, 360, because it's fourth quadrant. 360 minus what? 360 minus alpha, and 360 is now saying 2 pi minus what? Alpha. Are you getting it now? But don't forget the way to get your alpha, which is what? 2 pi minus, to get my alpha is just what? The tan inverse of what? Of minus y over what? X. Minus y over, not absolute value. But look at what happened here. For the principal argument, to get the principal argument on the fourth quadrant is simply if you have that is simply theta, which is equal to just minus alpha. You are not doing 360 minus anything, but don't forget how to get your alpha. So theta here is simply minus tan inverse of what? Absolute value of minus y over x. Please, very, very important. Okay, for principal argument on the fourth quadrant, we don't do what? We don't do what is it called? We don't do 360 minus. Okay, we just take the negative of what? Alpha. But don't forget that alpha is going to be what? This negative is because of what I'm having here, but alpha is equal to what? Tan inverse of the absolute value. Please don't forget that absolute value. That is for principal argument. Okay, so that is that. Okay, now let's get the argument and principal argument of the following questions. Okay, before we now enter into polar form. So they say find the argument and principal argument of the following. Okay. Okay, they said I question. I'm going to just use one simple question. They said that I is equal to z is equal to 1 plus root I root 3. Okay, number one question. Number two, z is equal to minus I plus what? I root 3. I'm going to use the same question. Number 3, I. Z is equal to minus I root 3. Minus 1 minus I root 3, sorry. IV is now Z is equal to 1 minus what? I root 3. Okay, so let us do that. Solution. For number one, which says that Z is equal to what? I plus what? 1 plus I root 3, which means that what? Don't forget that you write that Z is equal to what? X plus IY. So this implies that what? That my X is 1 and my Y is root 3. So you draw it. So let's draw. So let us draw. If we draw it now, we are having, if we draw it, we'll now have this. Watch me now. So I'm having that X is 1. Let me say that here is 1. Sorry, this is X axis, this is 1, while my Y is root 3. Okay, so if both of them, they are meeting at the first quadrant, you draw like this. So this is your alpha. Okay, so the first thing you get is your alpha. So my argument theta is the same thing as alpha, which is the same as what? Tan inverse of what? Y over X. Okay, which is what? Tan inverse of, what is my Y? Tan inverse of, what is my Y? My Y is X is equal to 1 and my Y is equal to root 3. Okay, so I'm having Y, which is root 3 over 1. Okay, which is root 3 over 1 is root 3. So tan inverse of root 3, what gives us root 3 is 60. So tan inverse of root 3 is what? 60. So my principal argument is what? 60. Okay. If you want to change 60 in terms of pi, you now say 180 divided by 60. If you want to change it in terms of pi, you say 180 divided by 60. 180 divided by 60. So I'm having 3. So pi is something as saying 180 divided by 3. Because 180 divided by 3 is what will give you that 60. So which is what? And 180 is pi, which is pi over what? 3. So my argument, this one is for argument. My argument is this. Then for principal argument, my principal. In first order, my principal argument is the same thing as my argument. Okay, they are the same thing as my argument, because if you take the absolute value of this, is equal to what? Theta, which is equal to alpha, and alpha is equal to tan inverse of what? Absolute value of y over x. So which is same as what? Tan inverse of what? Absolute value of root 3 over 1. So which is equal to what? 60. Okay, and 60 degrees, which is what? Pi over 3. Okay, is the same thing for the first quadrant. But let's now go to second, third quadrant, so you will now see the difference. So I've solved this one. So for number 2, I don't know if I'm even obscuring what I'm doing. Sorry about that. If I'm obscuring. So number 2 said that z is equal to minus 1 plus I root 3. Okay. So let us draw it. You must draw it to know what you are doing. If I'm drawing it now, I have this. X, this is x plus IY. So my x is minus 1. So this is the negative of x. So it should be here. And this is positive of y. So it should be here. So here is root 3. And here is minus 1. So they met at the second quadrant here. And so here is my alpha. So for argument now, the argument is equal to theta, which is equal to what? I told you 180 minus theta. Why? Because it fell where? Sorry, minus alpha. Why? Because where? It fell at where? At the second quadrant. So what do I have now? 180 minus alpha for argument is what? Just ordinary tan inverse of what? Y over x. Okay, without absolute value. So which is what? 180 minus tan inverse of my y is root 3, but my x is minus 1. So you see there is problem here now. Okay, so what do you have now? You are now having that this is equal to 180 minus tan inverse of minus root 3. And tan is an even function, is an odd function, sorry. Only cos is an even function. What do I mean by that? Sine is an odd function because sine minus theta is certain as bringing the minus outside sine theta. But cos is an even function. That is the only even function we have. Cos minus theta is the same thing as cos theta. It doesn't change. You cannot bring the minus outside. It swallows it because it's an even function. But tan is an odd function. So tan of minus theta is certain as bringing minus outside and say tan theta. So if we bring this minus outside, it will make this place to be plus. So what do we have now? We're having 180 plus what am I saying? 180 plus tan this thing is 60. 180 tan inverse of root 3, which is what? 180 is it? Where I think there's a mistake somewhere. Okay, sorry. We are supposed to use plus here. Sorry, for second quadrant we are going to use plus here. Do you know why? Okay, let me tell you what to do. Okay, why we are going to use plus is because in second quadrant, for argument, you must get something that is within that second quadrant. And second quadrant is saying that you are going to get anything from 0 to 180. It will not exceed 180. So that is why we are going to use plus here, so that the minus in term will not change it to minus. Okay, please. So it will be minus 60, and this minus this is what? 120 degrees. You see, 120 degrees is an angle that fell within 0 to 180. You understand? We cannot use 60 because 60 did not fall within that. Okay, sorry, it did not fall within 0 to this. Okay, so that is why we are going to do 180 minus the 60, which is 120. This is for what? For what is it called? For argument. Okay, for argument. But for the principal argument, we will always take the absolute value. Yes, for the principal argument, we will always take the absolute value of it. Okay. So and I think it's the same thing here. It's the same thing here for the principal argument. Principal argument is same as what? 180 minus what? For the argument, we are going to use plus so that it will fall within. But for the principal argument, we are going to use minus. Why are we using minus? Because of the absolute value will take care of the negative here. So I'm going to have 180 minus tan inverse of what? Of absolute value of y over x. So I'm having 180 minus tan inverse of root 3 over minus 1. So absolute value will take care of this. So I'm having 180. Sorry about that. 180 minus tan inverse of root 3, which is equal to what? 180 minus 120. Sorry, minus 60, which is equal to what? 120. So you can put it in terms of pi. You can put it in terms of pi by saying 180 divided by this thing and turn it upside down. Okay, so let's put it in terms of pi. I can say 180 divided by 120. So what did we have? What do we have? Okay, 0 here, 0, 3 here, 4. So okay, 2 here, 6, 2 here, 9, 3 here, 2, 3 here, 3. So I'm having 3 over 2. Okay, turn it upside down to become what? 2 pi over 3. Okay, you have to turn it upside down. So this is it as saying 2 pi over 3, which is what? 2 pi over 3. Okay, so you can check it by yourself. It is correct. Pi is 180. 2 times 180. Okay, 360 divided by 3. You're having 120, correct? So that is that. Okay, that's for second quadrant. So for the third quadrant, I'm going to have the third quadrant IV. The third quadrant, I'm having that I. That z is equal to minus I root 3. Okay, so if you draw it, this is minus I and this is minus root 3. Yes?
The bill of record.
I'm coming. Huh?
The bill of record.
Okay, I'm coming. Okay, so if you trace them, you see they met at the third quadrant. Okay, so for the argument, just know that you are getting anything that falls within third quadrant. Okay, so you can do the magic by yourself. Anything that falls after getting your theta, you now do 180. Never you use 260. It's either you use 360 or use 180. Please don't use 270. Sorry, don't use 270. So I'm going to have here that alpha is equal to what? Tan inverse of what? Y over x. So my alpha is equal to tan inverse of minus root 3 all over what? Minus root 3 over minus 1. So minus taking care of each other. I'm having that theta tan inverse of what? Just root 3. So I'm having what? 60. So since I have 60 now, third quadrant should be what? I told you we don't use 270. So, but we are going to find something that is within the range of 1. That thing will be greater than 180, but it will be less than 270. So what do? Just say that your argument is equal to what? 60 plus 180. Okay? That is when you get something that is close to that. So, if you add it, you are going to have 60 plus 180. You're having 240. You see, 240 falls within that range. And if you now say 240 divided by 180, if you want to put it in terms of pi, okay, you can put it in terms of pi. So pi is 180. If you remove 180 from here, if you divide it, let me say 240 divided by 180. So 0 cancels 0. 2 divide here, you're having 12. 2 divide here, you're having 9. 3 divide here, you have 4. 3 divide here, you have 3. Okay, so this is them as saying 4 times 180, 4 times pi divided by 3, which is what? You are not turning it upside down because it has exceeded the 180 that is pi. But if it is less than that 180 that is pi, you have to turn it upside down. So I'm not turning it upside down because it has exceeded the 180. Okay, so you check it yourself if it's correct. 4 times 180 divided by 3. Are you getting this number? If you are getting this number, then you are correct. So the last one here is what? Okay, sorry. The argument you get the principal argument you get the same thing. The principal argument you get the same thing. The principal argument is the same thing here. Alpha minus tan inverse of absolute value of y over x. So you are getting the same thing because minus already taking care of this. Okay, so that principal argument, I think where there is problem is in the second quadrant and the last quadrant. Okay, so that is that. So for the last quadrant, which is z is equal to what? Z is equal to minus 1 minus I. That's the last one. Minus 1 minus I root 3. So if you draw it, you're having minus 1 here. Okay, this is... Okay, sorry. The last one is 1 minus... Okay, so I'm having 1 at the right-hand side and then minus root 3 here. So they fell at the fourth quadrant. So I'm having my alpha here. So for argument here is simply 360 minus what? Alpha. Because you are going to get something that falls within the range of that from 270. It will be greater than 270, but it will be less than 360. So you are going to get anything that falls within that range. In fact, I'm going to use plus because of the law of tangent. I'm going to use plus here. So it's going to be what? 360 plus tan inverse of y over x. So which is what? 360 plus tan inverse of minus y is what? Y is minus root 3, yx is 1. Okay, so minus tan is an odd function, so minus will come out. So I'm having 360 minus I hope you know, tan inverse of 60, tan inverse of root 3, which is what? 360 minus 60, which is equal to what? 300. So to get it in terms of pi, you can say 300 divided by 1/8. Remember that you are not going to turn upside down because it has exceeded. This cancel this, 15 here, 9 here, 5 here, 3 here. So you're having what? 5 pi over what? 3. So 5 pi over 3. Now, but the principal argument for the fourth quadrant is the principal argument for fourth quadrant. The principal argument for fourth quadrant is simply minus alpha. That's all. It's simply minus alpha. So principal argument is equal to what? Theta, which is equal to minus alpha. So it's equal to what? Theta is equal to what? Minus tan inverse of what? Tan inverse of the absolute value, absolute value of what? Y over x. Okay, so what do I have now? That theta is equal to what? Minus tan inverse of what? Root 3. Okay, which is what? Theta is equal to what? Minus 60. Okay, so that is that. So you can put it in terms of pi by saying 180 divided by this and then turn it upside down. So that is that. So in fact, the only place principal argument changes is in the fourth quadrant. That is the only place it changes. Principal argument and argument are the same thing everywhere except in the fourth quadrant. Okay, in the fourth quadrant, that is when you now have that is only minus what? Minus alpha, and alpha is now what? The absolute value of tan inverse the absolute value of y over x. Thank you very much for watching. I appreciate it.